while using Arduino and trying to do many tasks at the same time? If yes, then this video is for you. This video will teach you how to do multitasking with Arduino. Let's say you want to execute several tasks at the same time. For example, reading data from the serial monitor and blinking some LEDs, monitoring some external sensors, sending data to the server after some time period, and blah blah blah. Here things turns out to be a little bit complicated. Why? Why is it complicated? The problem is that Arduino is not built to multitask at the same time. I know it's heartbreaking. It is only capable of executing one instruction at a time. Arduino does not have multi-core processors like any other classic computers you have, so you cannot really use the real parallel programming here. But what we can do is we can do some tweaks that can make you feel like you are doing multitasking. So without discussing any further, let's move to the main focus of the video, how to do multitasking. For this, let's make an example project where we have to do 4 tasks at the same time. Don't be confused. The same time actually means just giving you the feeling of the same time, okay? So the first task is task number 1, blinking an LED every 1 second. And let's suppose it to be green LED. And another task number 2, is glowing an LED whenever the button is pressed. Let's suppose the LED to be red. And task number 3 is controlling the brightness of LED by the user input. So let's suppose it to be blue LED, and the user will provide input of a number from 0 to 255, where 0 means totally off and 255 means full brightness. And the last task is task number 4, printing brightness of LED 3 after every 5 seconds. So up to now we have defined our project. For doing multitasking, what we need to take care about is Arduino runs code one by one. We don't want to get stuck in one task for a long time. We want to rapidly cycle over tasks without waiting at one place. So to make it clear, let's just try to perform task 1 and task 2 in Arduino code. For task 1, let's define pin 13 for green LED. And for task 2, let's define pin 12 for the red LED and pin 4 for the push button. Now let's configure the LED 1 and LED 2 as output and button as input pull-up. Here button is connected to the ground. When pressed, Arduino reads it as 0 or else as 1. Now let's make a blinking code for task 1. Waiting for a second, turning on the LED, again waiting for a second, and turning off the LED. And that's it. That's the blinking code. And for the task 2, when digital read is high, it means that the button is not pressed. So we need to turn off the red LED. If digital read is low, it means that the button is pressed. So we need to turn the LED on. The hardware arrangement is like this. Let's upload and check if it works, okay? Here you can see that the green LED is blinking, but whenever I press the button, red LED is not glowing. So what must be the problem? We press the button, but the Arduino is still in task 1. To read the button press, we need the Arduino to be executing this code. But when we press the button, it's still busy executing task 1, and Arduino won't be able to read the button presses. Okay? That is why I say we need to cycle over tasks rapidly. So task 1 is really making a problem for multitasking just because our program is paused there. In our project, are there any other tasks that may pause the program flow? Yes, there is. It's task 4. We need to wait for 5 seconds and print brightness, right? So we now know that task 1 and task 4 needs to be reformed so that it won't pause the program flow. We can do that by using millis function. So what is millis function? It counts the time in milliseconds since your Arduino powered up or reset. We can use it instead of delay. To see how, let's check this code out. Here in the code, previous time saves the time when the Arduino is powered on and then goes to loop function. And current time saves the current time count after the Arduino is powered on. Current time increases every millisecond. When current time is greater than the previous time by 1000 milliseconds, then do something function is called, and the previous time will replace the value with the current time. Again, whenever current time is greater than the previous time by 1000 milliseconds, then again do something is called, and again previous time will be the current time. This cycle goes on. Do something function runs after every 1 second without pausing the loop cycle. Now we know how to use millis function. Let's use it in our project code. Let's define pin 11 for green LED used for task 3. As we use green LED for brightness control, we have to use PWM pin. So we choose pin 11 for it. And make previous time variable for T1 and T4. Also, let's define interval for T1 and T4. We use 1000 for T1 because we need the LED one to blink every 1 second. Also, we use 5000 for T2 because, it's T4, because we need to print brightness for LED 3 every 5 seconds. Now in setup, we will initialize the serial communication with 9600 baud rate and also configure LED 3 as output. Now it's time for writing task. For task 1, we will change the code with millis code we used before. Now replace to something with digital write LED1 state. Whenever this if condition becomes true, we want LED1 state to be just opposite of the one it was before. For that, add LED1 state equals complement of LED1 state. Since we are using LED1 state variable, we need to define it. Let's go to the top of the program and define LED1 state equals low. Let's also replace previous time with this and also interval 1000 with this. Leave the task 2 as it is because it is not affecting the loop cycle. Also for task 3, if data is available in serial buffer, read the input as integer and store it as brightness. We will make brightness as global variable because we will need it in task 4. If brightness is between 0 and 255, we will write LED 3 with brightness value. Again for task 4, we will use millis function as it is to be executed every 5 seconds. So let's paste the code we have used in millis explanation and replace do something with serial printing code for brightness. Let's also replace previous time with this and interval 1000 with this. Now we are done. Now our loop function will not be paused by task. Execution time may affect a little bit, but that's pretty good. Let's upload it to the Arduino board. The final hardware arrangement is like this. I hope you can make this circuit easily in the breadboard. Let's check it out. Green LED is blinking, which is task 1, and it's fine. Also, let's check task 2. Whenever I press button, red LED glows without affecting any other tasks. It is also fine. Now let's check task 3. For that, first go to the serial monitor and at the bottom choose no line feed because we want only the input data and not any other characters out there. Type 100 and hit enter. Now blue LED glows with the brightness of about 40%. Also you see tasks 4, right? You can see task 4 in serial monitor. Brightness is printed every 5 seconds. Again type 255 and hit enter. Blue LED glows with full brightness. Okay, fine. Task 3 and task 4 are also working with our problem. So that's it, we did it. You better try with something more complex like controlling 7 segment display, servos, or whatever you like. Just the same concept applies out there, maybe with a little bit more tweaks.